All right, on to our next example. Somehow it's a numbered example form, not sure why. So again, just the exact same steps as the one before. We'll start with our y-intercept, which is plugging in 0, 4x into the function. So we're gonna get a 0 squared, and then we're gonna get stuff down here. I don't really care what's down there as long as it's something, it's a 4. So 0 over anything, gonna give me a 0. So we're getting a y-intercept of 0, 0. All right, on to the x-intercept. X-intercept coming from where the function equals 0, so where the numerator equals 0, well, x squared equals 0. Only thing you can really do there to solve it is the thing called the square root property. So you can say that if x squared equals 0, we can take the square root of both sides. Square root of x squared gives me x. Technically, this is where you use a plus or minus. However, since the square root of 0 is 0, there's really no point in putting a plus or minus in front of that number 0. So that here is where we've let the function equal 0, so that's our y value, found out that that's our x value, so we're getting a point of 0, 0, which happens to be one we already knew, but that is now also both a y-intercept and an x-intercept. Moving on to the vertical asymptotes. That comes from our denominator here, and taking that function, that polynomial, setting it equal to 0. This can factor very conveniently. I'll go ahead and start with this. Numbers that multiply to positive 4 but add to negative 2 would be negative 2 and negative 2, which I'm going to go ahead and point out is the same factor squared. So really only leads us to one solution, x minus 2 being set equal to 0, giving us, giving us x equals 2. Oh, man. There we go. So there's our equation of our vertical asymptote. And then over here, for the horizontal asymptote, notice another situation where we're looking at x squared over x squared. So n and m are equal, right? N equals m. So we're going to again look at the ratio of the lead coefficients. So y equals, and so this is a 1x squared and a 1x squared. So it's going to be y equals 1. And then the question, once you have the horizontal asymptote of does it cross, that's the question of does this function equal that y value? So we take our function, multiply both sides by the denominator, so it cancels there. And on this side, we're simply multiplying it by 1, so we're going to get that expression. X squared equals x squared minus 4x plus 4. Now, as soon as I see the x squareds on both sides, if I were to say let's move them or subtract them, they're going to go away, which is nice because now you know you're in a linear equation. So now I'm just going to focus on solving for x, just getting x by itself. 4x on the left equals 4. Divide both sides by 4. Get x equals 1. What this means is we ask the question, does our graph cross this horizontal asymptote by writing out this equation and solving it? And it does. It crosses at an x of 1 at a y of 1. I believe this is another situation where these two numbers match, and that is again a coincidence. But this tells us that yes, it crosses, and it crosses at the point x is 1, y is 1. So now we will take this information, well, it's somewhat limited, and we will use it. Let's put this information on our graph first. So both x and y-intercept being the same point, 0, 0, giving me a dot right there. Our vertical asymptote of x equals 2, giving us a vertical line there. Horizontal asymptote of y equals 1, giving us a line, giving us our horizontal line there. And then the graph crossing our horizontal asymptote at the point 1, 1. So that would be a point right there. So let's go ahead and go back real quick and point out two things before we jump into this graph. our x-intercept and our vertical asymptote have multiplicities that we can observe, and specifically notice this 0, this one x-intercept, came from a factor of x squared. There is an exponent on the factor that led to a 0. That exponent is 2, so this x-intercept has a multiplicity of 2. And remember, for intercepts, for these points, even multiplicities meant our graph is supposed to bounce off at that point. So we want to keep that in mind. Also coming down here to the vertical asymptote, where this one solution, this one asymptote, came from a factor that was, again, squared. So this horizontal or vertical asymptote also has a multiplicity of 2. And for asymptotes, recall multiplicity of 2 told us we were going to actually see the same infinity, not the opposite ones like we saw with the multiplicity 1. So using that information, coming back to the graph here, first thing to point out, as we saw with the work, we know our graph will cross this horizontal line, as we see right here. To go from this point to this point, obviously our graph is going up. As it goes up, it's going to be forced to continue upward and then asymptote against that horizontal asymptote. So I'll go ahead and draw him following that behavior, going up like so. No, and I'll even point out, notice there's no chance that it bounced off here or hit here and came down because we don't have any other x-intercepts, right? There's nowhere else this graph is allowed to cross this x-axis. So we know for sure it's going up like that. From here to the right, we got this. Now going to the left of this point, it is actually because of that multiplicity of 2 that we have for this one point, 0, 0, multiplicity 2, that it bounces off of here. Now, to bounce off this point, it doesn't just go up and off like that, like a parabola. Because if it did, we would have another place it would have been crossing this asymptote. We would know it. We would have found that information, and we don't have it. And also, it would not have this kind of end behavior because we need to have the end behavior of this horizontal asymptote. It needs to be asymptoting as we go off to the left. So what actually happens is it does bounce off. It stays above the x-axis, but it very quickly just flattens out and asymptotes to that horizontal line as it goes off to negative infinity. So this piece of our graph, again, basically half of it from our x vertical asymptote there, the left half, this follows all the rules. Goes to those 2 points, bounces, but then asymptotes both horizontally and vertically. So there is our first, again, half of our graph. We're in the same scenario where we know nothing about the second half, but we still know something. We know there's no x-intercepts, right? No crossing of this x-axis here. There's no places it crosses the horizontal asymptote, but we also know, because of the multiplicity of our vertical asymptote, we know we have the same infinity behavior on this vertical asymptote. Meaning, if this went to positive infinity on the left, it goes to positive infinity on the right. And it comes down from there, and again, no other information of crossing, so just as a sketch, it's got to have that behavior of, again, being stuck in this top corner here, where it just asymptotes vertically and asymptotes horizontally.